Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we're going to talk about conjugates of complex numbers, all right? So we're going to talk about what's the concept of conjugate and how do you go about it and what is going to be the impact in your arithmetic, okay? Before I proceed, don't forget to like, share, and subscribe. If you've not clicked notification bell, I don't know what you're waiting for. Please click do so that when I post new videos, you'll be the first person to know, all right? So when we talk about when two complex numbers are conjugates, means that they are both identical except for the middle sign. So for instance, you know that we've agreed that let's say we have 5 plus 7j. This is a conjugate, right? So the 5 here is the real part, while the 7 here is the imaginary part, right? Now the conjugate now will be when they are both identical, but you have both 5 and 7. But the difference here is that instead of having the positive sign, you're going to have a what? A negative sign. So this is what we call conjugates. So they are conjugate numbers, and there's a relationship between both of them. Is that I'm going to talk about it, that the conjugate is same thing as the square of each of their parts, the real part and the imaginary part. So I'll talk about that very soon. So so because I know students do take notes from my videos, so I'm gonna write down what I just said, okay, so that it will be easy and for you to revise. So now, two complex numbers. All right, so two complex numbers are conjugate when they are both identical, except for the middle sign in the bracket. Okay, so two complex numbers are conjugate when they are both identical except for the middle sign in the bracket. So let's assume we have 5 plus 8j, okay? And the conjugate should be 5 minus what? 8j. So these two are conjugates. Does that make sense? So they are conjugates. Making sense? While if you now have this one, 5 plus 8j, and we now have minus 5 minus 8j. Now, these are not conjugates. Okay, so these are not conjugates. So the first one, because they're identical, except in the sign here, okay? But this one, they are not conjugate because although they have different sign, the 5 here are what? Different. So remember, they have to be identical except for the middle sign between them. Now, the next thing as well is that how conjugates are written, we usually use an asterisk mark to represent conjugates, okay? So conjugates are always written with asterisk marks. So conjugates are usually written with asterisk signs. Okay, so they usually use the asterisk signs to represent conjugate. So for instance, so if we have z is equal to 4 plus 2i, then z asterisk, are you seeing it? Will be equal to 4 minus 2i. So sometimes when we want to give you some questions, or you go to the worksheet or the textbook, you will see that they will give you asterisks, and that should represent conjugate. So if they tell you that, for instance, z asterisk, so now it's telling you that the z has to be multiplied by the conjugate of z, something like that. So you need to be very careful. Several questions can come in different ways. So just so you know, now when we talk about asterisks, is what we talk about conjugate, okay? So now what we now, then if you now have those conjugates, so now in this case, when we had z asterisk, okay, and that was equal to 4 minus 2i, like from the above, right? Now this pair is what we call the conjugate complex number. So this, for example, is referred to as conjugate complex number. All right. So those complex number are referred to as conjugate complex numbers. All right, so now let me pick an example. Before that, let me just write down the steps on how to play around with conjugate, because I know that students do take notes, so that when I want you to take note of some of the rules, okay, of conjugate and how to go about it is very important, because there's some similarities and there are some shortcuts as well. And I'm going to pick an example and explain. All right, so let's say so there are 3 rules, okay, or 3 steps. I usually use them interchangeably. So number 1, the product of 2 conjugate complex numbers is always real. So the product of 2 conjugate complex number is always what? Real. All right. So the product of two conjugates complex numbers is always real. All right. So always remember that. So that means when you have something like z multiplying z asterisk, is going to give you what? A real number. All right. It's going to just give you the real part of it. So you need to keep that in mind. So the product of 2 conjugate complex numbers is always what? Always real. So, and also another thing you need to keep in mind is that when you multiply, the multiplication follows all the rules we talked about in the previous video. So multiplication follows the 3 rules of multiplication of complex number. Okay, of multiplication of complex number in the previous video. Okay, okay, and also another thing to also keep in mind is number 3, okay, the product of 2 conjugates, which we know is always real, okay? The product of 2 conjugates is equal to the sum of the squares of the real and imaginary parts. Of the complex number. Okay? So what I'm saying, okay? What I'm saying is, for instance, if we have, let's assume that we have one conjugate is equal to A plus BI. So that means the A is the real part, the B is the imaginary part. And definitely the conjugate of that, Z asterisk, is equal to, let's say, A minus BI. So remember, they're going to be identical except in the except with the signs. So what we are saying is that, therefore, when you now have Z multiplying Z asterisk, is going to be the same thing as saying A squared plus B squared. Okay? So when a number and its conjugate is being multiplied, it's the same thing as saying the sum of the real part plus the square of the what? Imaginary part. All right. So let me pick an example here, okay? I'll just pick one example in this video. Then I'll give you some exercises to try. So let's say we have this example here. So we have, let's say we had 3 minus 2 j, and we have 3 plus 2j. So you can see that this both is conjugate because they are exactly identical, except they are different in the middle part here. All right, so let's go with it now. So I'm going to do the two methods. So I'm going to use the first method here. I'm going to use the long, multiplication of two brackets that we talked about in the previous video. And then I'm going to use the shortcut in the second one. All right, so let's do this. So we have something like this, right? Give it a bit space. Good. So we're going to go 3 times 3 is going to give us what? 9. 3 times 2j is going to give me what? Plus 6j. All right. Now we have minus 2 times 3. Minus 2j times 3 will give me minus what? 6j. And minus 2j times 2 will give me minus 4j j squared. But we know that j squared is equal to minus 1. So I can now rewrite it again as 9 plus 6j, right? Minus 6j minus 4 minus 1. Minus times minus will give me plus. So it's going to be plus 4 minus 6j plus 6j and 9. Are you seeing it? Then we know plus 6j minus 6j will cancel out because that will give us 0. And then we're now going to have 9 plus 4. And this is going to be equal to what? 13. And that's the answer. Now we're going to go to method 2. So in the second method here, I told you that if you're multiplying two conjugates, it's going to be equal to the sum of the squares of both the real part and the imaginary part, right? Okay, so let's go back here. So we have this one here. So then we can now say, because we're having two conjugates, it's going to be equal to the a squared plus b squared. So that will be giving us a here is going to be what? 3 squared plus the b here is going to be, you can say 2 or minus 2, does not really matter, okay? Then it's going to give us 3 squared, it's going to give us 9 squared, is going to give us plus 4, because minus 2 times minus 2 is going to give us plus 4. And then 9 plus 4 is going to give us what? 13. So you can see we got exactly the same what? Exactly the same thing. All right, so that was what I was just trying to explain in this video. So when you're multiplying two conjugate numbers, it's going to be real. Can you see? So if you look at rule 1, I told you it's going to give you a real number. So you can see we got a real number at the end. Also, is that it's also equal to the square, the sum of the square of the real and the imaginary part. See, and that is that. All right, so what I want you to do now, I'm going to give you some examples to try. All right, I want you to try this. So we have the first one I have here. I have this 2 plus 7j and 2 minus 7j. Number 2, we have 4 minus 3. Okay, and we have 4 plus 3. Number 3, we have x minus jy and x plus jy. Number 4, we have 4 plus j7, and we have 4 minus j7. Number 5, we have a plus jb, and we have a minus jb. All right, and that is that for that. So try this. You can discuss with a friend, or you can put the answer in the comment section, or if you're having any issues, send me an email and I'll get back to you as soon as I can. Okay, so quickly, we'll go to the next video, which is going to be division of complex numbers. And if you have any question, please don't hesitate to send me an email and I'll get back to you as soon as I can. All right, so I'll see you soon. And we'll talk about how to divide complex numbers, division of complex numbers. See you soon.